Hello, everyone! Chapter 4, Polynomials, Learning Target 3. Oh my goodness, I'm so excited! This is Miss Osier.
And Miss Lahar.
And here we go.
All right, so basically this learning target we'll give you a certain situation, and you have to come up with the correct formula that matches that situation.
Wow.
So there's really not teaching. Yep, we're going to show you by example, really.
Okay, so create the equation of a cubic in standard form that has a double zero at -2 and another 0 at 4. The cubic has a y-intercept of 16. Sketch your cubic on the axis below to verify your result. Notice how I'm very annoyingly saying cubic.
Because that gives you a hint that when you get done, your expression should be a cube function, which means it should have a highest degree of 3.
Correct.
All right, then you focus on what information you're given. The fact that we have a double zero at -2. Remember, if it's a 0 at -2, what was it before you solved for
X? It was a x plus 2. It was a factor.
Okay.
The double zero is referring to the multiplicity. So that means I have a multiplicity, double means 2, of 2.
So that's why that one has an exponent of 2. Then we have another root at +4, so I knew that before it was an x minus 4.
Fantastic.
All right. Then
now you'll notice this little a there. Well, that's because we also need to know something about the leading coefficient.
Okay. We are given the fact that y-intercept is 16. That's a coordinate point.
It is. The coordinate of the y-intercept of 16 is 0, 16. Remember, every coordinate has an x value and a y value. So plug the x value in for x and the y value in for y. X equals 0, y equals 16. Solve, solve, solve.
A equals
Boom.
-1. Now, don't just leave it like that. You got to put it back into a nice little expression. And to be honest, you can check this if you need to make sure it crosses at the -2 and +4.
You sure can. Just wanted to remind you, or not remind you, but suggest. Sometimes it just gets like, oh, I have to rewrite the whole thing. If you're using pencil, just hop right back up here, erase that A, and put a -1 in, and circle that bad boy.
Yep. Now, it does say oh, no, we didn't do it. Oh, and then it does say sketch. Okay, so sketching we're going to get more into, but we're just kind of giving you an intro.
So it's a cubic function. So I know it's going to start and stop in opposite directions. I proved that my leading coefficient is negative, therefore it's ending down.
Okay. We have roots at, I did put it in standard form.
Oh, look at that.
Yep. So standard form means that it's in not factored form. What it was originally in was factored form. Standard form means using all of your polynomials and simplifying it as such. So I've done that. X plus 2 times x plus 2 is x squared plus 4x plus 4. Then we went through and distributed all that wonderfulness, which is located underneath.
Yep, right there.
And then maybe I simplify.
Cleaned it up.
Oh, cleaned it up and negated everything.
Boom, there we go.
So that is in correct standard form.
And remember, it's a cubic function, so that's a 3rd degree.
Now I think my sketch happens. Yep, roots at -2 and +4. Y-intercept is 16. We just connect those dots, and that looks like that.
Boom.
It's just a sketch. So
and we know it touches here. We know it boops, because that multiplicity of 2. So I know I go down, and I boop, and I come back up, and I whoosh through.
So there's one example. Now I think we do a different type. Okay, a little bit different.
Okay, so is the degree even or odd?
Look at that graph.
Even.
Definitely even. They end in the both
I
spots.
forget that you can't see me sometimes. I'm doing my dance.
She is doing her dance. Her hands are up in the air. B is a leading coefficient, positive or negative. They're ending up, so that means positive.
Positive. Value of the constant coefficient. Okay, don't get thrown off here, people. In standard form, the constant coefficient is always plus something, right? It's always the thing that doesn't have an x. So that means if everything else didn't exist, that would still be there. So it's always going to be your y-intercept, because if you plug 0 in for x, it's what's left. So your y-intercept will always be your constant coefficient.
So we just look at our y-intercept, which is -3. There we go. Now identify the real zeros and state the multiplicity. That's what we did yesterday. So we have one at -3. We know it's even because it boops at the axis.
Right. We can't, like, I would go with 2. That's a quick boop. But technically, if you just said even, that would be acceptable, because we don't know if it was like a boop or a boop. We don't know which one it is.
All right, the next root we have is at -1, and I know it's definitely odd because it goes right through that axis. Whoosh. Look at that sound effects. Now we have 1. Boops back down, so I know that it's an even. And then we have 3, and we know it goes right through because of that beautiful sound effect. There we go. Now, E has to, you have 4 graphs to pick from. Okay.
This one.
Now, I think I go to another slide to give myself some room because this is the concept where we set up our equation and we solve for a. So again, we have a root at -3, so you see how I have x plus 3 and I've put a square there because it's a boop. Okay. Now we have one at -1, so that would be x plus 1 before you solve for it. And then at +1, you would get x minus 1, and it would be a square because it boops back. And you have one at 3, and then that has an odd multiplicity, and it's 1 because it goes right through.
Boom.
Now, what point have they given you from your graph? Right there. So you just got to plug in your x and your y, and look at all that solving. So we know that -3 divided by -27 would end up being +1/9. So their choice 2 is your winner.
Look at us go.
That's all there is to it.
Sorry, chicken dinner. I didn't.
Winner, chicken dinner, baby.
I didn't take it. Oh, look at us go. All right. Have a wonderful day, everyone. We will see you later and in class.